Yes, welcome. We are going to be going through the implementation of MLOps for audio separation. Um, Briefly, this is the overview. First, the objective was to develop a deep learning based audio separation using CNN and spectrogram images. As we all know that CNN, that's the convolutional neural networks, it uses images mostly. But now here we are dealing with audio source separation. Therefore, we are dealing with audio data. Hence, we had to first turn them into spectrogram. The audio signals are turned into spectrogram images, which are then later fed into the CNN model. Have the MLOP, utilize the MLOP flow, the machine learning flow for experiment tracking and model versioning, and then automated deployment. We utilized open source tools like Librosa, TensorFlow, Keras, also PIL, and the Matplotlib for visualization. In pre-processing of the audio data, we had Librosa used. The Librosa library used it for loading the audio mixes for pre-processing. Then in pre-processing, basically there are three, where we have resampling, normalization, and trimming. So in resampling, we ensure consistency of the sampling rates. Typically, we used the 44,100 Hz, and then normalization. We standardize the audio amplitude for stable training, and then trimming had to remove the leading and the trailing silence for focus. Then in transformation, transforming audio into spectrogram, we had to convert the audio mixes into spectrogram representing using Librosa. Then visualization, the spectrogram are visualized using the Matplotlib, and then we saved them and use them as input for the model, the CNN model. That snapshot shows the spectrogram that we developed. So in training and evaluating the source separation model, first of all, the setup, we utilized the ML flow for experiment tracking, and then the data set for training, validation, and evaluating. The data set, we use the DSD 100. And then training, we employed the argumentation technique to improve the generalization. And then logging, we use the log model parameters, matrices, and then the artifacts with the ML flow. So it also used the MLUI. The MLUI used it, the ML flow UI, to visualize the experiment results and monitor the model performance. Other challenges that we faced, you had the data set. We used a small one, the DSD 100. The smaller version is the one we used. Then they're keeping the version consistent, dealing with audio data, since we are using the CNN model, which basically uses images. Then integration of new tools. How we address those challenges is by adding more data, more training data into the data set, since it had very few songs. I also used Git for version control. We watched tutorials. We also utilize the documentations. These are the impacts of ML flow. In ML flow in implementing the audio source separation. So first, benefits are scalability, reproducibility, then efficient gains. So scalability ensures efficient handling of varying interface loads, then ensures easy replication and verification of results, streamlines the model development lifecycle, have feature enhancement, the model architecture, to explore advanced architectures like attention mechanism, then training techniques, experiment with transfer learning for improved generalization, then deployment strategies, optimize strategies for real-time interface. Wow. So let's these are the links, link to documentation, link to data set, the link to the model which is already on render, The final model is already working on render. Then link on to Grafana. So let's dive into the code, and we see so this is our code. As you see, in the folder I have the DSDR100 dataset, the ML artifacts, the ML runs, the spectrograms, the template, training model. You have the uploads. Then this is the model. First of all, what we did, we imported the OS, we imported the necessary libraries as we talked about them in the slides. Heartslib browser, the MATLAB, the Matplotlib. We imported the Keras, the ML flow for tracking. So first of all, in the code, we set the tracking URI for the local directory. That's using ML flow. We use this local host. Then we configure the dataset for the path for the dataset. Then this is audio processing. As we said, there are three stages. First, resampling, where the target was 44,400 Hz. Then normalization, there is trimming of the leading and the tailing silences. Then we generated a spectrogram here. In this, we plotted it and then saved it, because it's the spectrogram image that we're going to use as input for the model. Here we already did the song, the data set, from the data set, which is going to be processed into a spectrogram image. Then here, so we built the model. These are the layers, there's max pooling, and all the necessary layers of the model. Then here we feed the this is the for training the model, the function for training the model. Then this is for evaluation, and this is for saving the model. Here, this is where we call the functions by putting the song. Here we put in this, we call the songs, and then the spectrogram here is saved. Then we load the after loading the song for training, and then training the data, and then saving the data. Then after testing, then evaluating the model. Thank you very much. My colleague will be proceeding from here and giving us the remaining part of the code.
Hello friends, this is Kaitasi John, and I'm going to take you through how we deployed our model. Yes, so this is the Flask app that is handling the model, where we imported the necessary libraries and configured our Flask app here. We configured it in a way that when one uploads an audio, it only allows audio in a .wav format. And then here, after one is done loading this, it will pre-process the audio where it resamples it, normalizes it, and then trims off the silence. Yes, then we loaded our pre-trained model and started handling the pre-processing, where it checks whether this request is a post request, and then handles the pre-processing of the audio. It feeds it to the pre-trained model, and later outputs the different sources from in a downloadable format. And then we configure the uploads and then use ports 5002. When you look at the HTML templates that is handling that, we have the index where when one uploads a song, they will pre-process it, fix it to the trained model, and they will output an audio. the outputs, the different sources, sources of this mixture in downloadable formats. Yeah, we have the datasets, we have these other artifacts and ML runs. We have these were the samples. We saved the samples. We wanted to look at the structure of the images. The spectrograms, yeah, they're also images. These are the templates. We have our trained model, the app that is handling the model, and the code where we tested and trained our model. And these are our requirements and the readme file. Yeah, let me briefly take you through the deployments. So we used render to deploy our model where it's live. Yeah. So our model is live when you look. Yeah, our model is deployed and live. So when you copy this code, when just copy this link and paste it, this is the interface where one can choose any file, any audio, as long as it's in a .wav format. So when we choose this sample with this one, when we upload this file, yeah, it's running, but it takes some little time. Let me be taking you through. We're going to go back to the output. So for the settings, we used Python 3 for our model. And for, yeah, it's called final model. We used Oregon for that's the region where our service is running. And then that is the repository. This is a repository to our code in case anyone wants to maybe integrate it in their projects. Then it's on branch model 1. Yeah, we have the requirements, and then this is our API in case anyone wants to use our model in their projects. So we used, this is the MLflow UI, and we have a number of columns. So this is helping us track our model, the performance, and yeah, we have the dataset, the user, the source, the version, the models. For the metrics, we looked at accuracy and loss, val accuracy and val loss. Then for parameters, we looked at the branch size and the learning rate. Yeah, we also used Grafana, where it helps us in the visualization, help us in tracking the performance of our model. It provides us with insights and analytics of our model. Yeah, so these are the different servers where our model is being handled. And for example, it's in Amsterdam, Antilata, Cape Town, and others. So we have the uptime. So the uptime is just a time, is a time taken for one to establish a connection to our model. And then this is a reachability, the ability for one to access our model. And then the latency, the time taken for one to respond to the request. And we also have the frequency. Yeah, that's basically it. When you go to our Git, this is where our code were hosted. It's public. Anyone can access it as long as you have the link. Yeah, we documented everything. Thank you very much. This is all I have for you. Thank you.